In today's lesson, tributaries combined probabilities. So the first thing we have to learn about, takadzidza kuti probability, it's simply a numerical measure of the likelihood of an event happening or not happening. So let us rewrite this definition because yati tawedzera ma descriptors pairi. So when we talk about probability, is a numerical measure of the likelihood of an event happening or not happening. Okay, I want to ask a few questions. Takati, if we have an event A which is certainly going to happen, saka chinhu chinotoitika, probability yacho inenge iri chi? Anyone who cares to answer? Inenge iri 1, correct. Saka the probability of 1 means an event will certainly happen. Then the probability of not A yatinogona kunyora is the probability of A complement. In this case inge equal to chi? Inge equal to 0. Zoreva kuti certainly an event will certainly not happen. And these are the extremes. Kokana tikava ne probability ya B panenge paine an equal chance of happening and an equal chance of not happening, what will be the probability? Correct. So if we have an equal chance of happening and not happening, trikutaura about a half probability, which is 0.5, or you can write it as half. So this is what we have learned. We defined probability as a numerical measure of the likelihood of an event happening or not happening. An example yatakaita in our previous lessons: if it has rained in Gwanda in 9 out of 12 Septembers, then statistically the probability of rain falling in Gwanda next September is 9 over 12, which is also 3/4 or 0.75. Saka example yandapai, we learned it under experimental probability. This is an example of experimental probability. What is experimental probability? Basing our probabilities or the chance likelihood of something to happen on its past record. Since experimental probabilities use numerical records of past events to predict the future, its predictions cannot be taken to be absolutely accurate. So as we explained in our yesterday lessons, there is a 9 over 12 probability of rain in Gwanda in September this year. Tinogona tirikungotaura tichiti chance yekuti kunaya yakakura, but kunogona kusatonaya. Saka experimental probabilities, they are not accurate. Of course, tino expecta kuti ma patterns angaripo in the past are influence the future, but sometimes you can have external shocks. Climate change inogona kuita kuti kusanaya. Climate change is an external shock. Mapaona. Saka ma past patterns can be disrupted by external shocks like natural disasters, and kukaitika an earthquake zvinogona kuita influence ma patterns of the past. Alternatively, the probability of throwing a 5 on a fair 6-sided die is 1 over 6. We learned about die throwing. Those who didn't attend, I sent the video. Since any one of the 6 faces is equally likely. This is an example of theoretical probability. Theoretical probabilities are exact values which can be calculated by considering the physical nature of the given situations. Saka under theoretical probabilities takatarisa coin tossing ne die throwing. So this is just a rough revision of what we were working through. Let us now have two examples and see how we can best move. As I bring the examples, are there any questions from any one of you? This is our example number 1. Tendai and Samuel have played each other at tennis 15 times this season. And saka 15 times yatatopiwa panapa, this is a complete set. So you can actually say munogona kunyora kuti your sample space is made up of 15 games, 15 tennis games. Saka munonyora about the sample space pamunenge matoona kuti this question is on probability. Tendai and Samuel have played each other at tennis 15 times this season. Tendai has won 12 of the matches. So let me say kuti maverenga question yenyu, then you catch the subject of the question kuti it's a question on probability. The moment yamunoona kuti question yenyu ndeye probability, then you start noting down the important information. Tatanga ta identify a sample space. For the benefit of vasina kuatenda kana kuona our previous lesson, kana chiti sample space trikutaura, this is the whole set of observations under question. Saka magames mangani atiri kucalculate probability on? There are 15. That is what we refer to by sample space. Saka Tendai and Samuel have played each other at tennis 15 times this season. Pari kunzi Tendai has won 12 of the matches. Tisa tatomboenda kure tinogona kutocalculate the probability of Tendai to win. Saka since Tendai akawina 12 mamatch, iwo mamatches akatambwa ari 15, zvoreva kuti tichati 12, which is the required outcome. Remember, this is the required outcome, which we can write as the number of elements of, say, R over all the possible outcomes. And by the way, this is actually experimental probability. Saka possible outcomes, which can be written as the number of elements of the sample space, like that. Saka tokunangoiseri 12 over 15 for now, because atisataziva kuti question iruda kutofunza chii. So zvanzi, they play each other in a championship. What is the probability that A, the match is drawn? Saka A, truda the probability of a draw. Saka this might sound unfair kana musiri familiar with the game of tennis as I am, because this question, had I not done a little research, I wouldn't have been able to answer it, because tennis yacho handitoisivi. Apparently, tennis matches are either won or lost. They are never drawn. Ndasingazivi kuti kutennis hakuna draw. Saka since kutennis kusina draw, probability of a draw inenge iri chi? Inenge iri 0, because a draw can never happen. Saka the probability of something which never happens is 0. Saka the probability of a draw is going to be 0. Are we together there? Then apo parikufunzwa the probability of Tendai to win. Patanga titoverenga question tabva tatoita. So the probability of Tendai to win is equal to 12, the number of times Tendai wins, over 15, the games Tendai plays. We can simplify this by use of 3. 3 into 12 and 4. 3 into 15 and 5. So we can simplify our answer to 4 over 5. Canary paper 2, you can write your answer as 0.8 after putting this through your calculator. Saka kana tikatarisa nekurangarira the spectrum of probabilities, we learned kuti it's 0, impossible, 1, absolutely possible. Saka 0.8 ingeresa mwipanapa. And it makes sense kuti chance yatendai kuti awine ihombe nepamusana pekuti atowina 12 kana kuti in the past akawina 12 games out of 15. That is why kana mchiona bhora munoona kuti whenever two teams are playing, especially in Europe, vanotipa a brief history of their encounters. Munoonza vachiti for the past 10 games Spain only won once against this team. Why are they saying that? Information iyoyo manje ndo inozotorwa nemabetting companies pavanenge vachicreata ma-probabilities, but ma-betting company hashandisi probability kazhinji, anoshandisa ma-odds. And in statistics, a probability and an odd are different. Ma-odds atimaite, saka there's no need of explaining anything, but ma-odds and ma-probabilities, they are different principles altogether. And I don't know why they prefer odds to probabilities. But the way of calculating an odd and the way of calculating a probability are roughly the same. Actually, the way of calculating an odd, it's how much games you have won divided by how many games you have lost. Chinongochinja ndechekuti it's not over all possible outcomes. That's the only change. Saka an odd trikuti it's number of favorable outcomes divided by number of unfavorable outcomes. Saka tikada kuwana, this is just extra, it doesn't matter, just kuti muzive. Tikada kuwana Tendai's odds to win, tinoti Tendai akawina magame angani 12, akadyiwa magame angani 3. Saka ma-odds acho angachi 3 into 3 1 into 12 4. Saka the odds for Tendai to win is 4. Tikada tsvaka the odds of Tendai to lose, tinenge takuti Tendai akaluza magames mangani 3, akawina magame mangani 12. Saka inova reciprocal iyo 1 over 4. Alright, rega ndifunze this question, anyone to answer? What do you think is the probability of Tendai to lose? Apa payanga iri apa takacalculate the odds of Tendai to lose. Ndavunza the probability of Tendai to lose. 3 over 15, 1 over 5, correct? But I would be more happy dai answer yenyu yangoti 0.2 nekungotarisa panapa. Complementary. Not 1 minus probability of winning, kuti tiwane probability of losing. But your answer is also equally correct. Okay. Saka we have calculated the probability of Tendai to win, and sevangu vaizvifarira chose vakatsanangura chinhu chiri outside scope yesyllabus. Vaityika kuti ndipamusana pekuti vanhu we are naturally rebellious. Tinonyanya kufarira zvatanzi musafarira. You can do a social experiment. Ngotora ikabepa chiro kasina kunyorwa chinhu, moinstructa vanhu kuti musavhura bepa iri kana kuti musasvika padhuze pandiri panapa. Before mataura that instruction hakuna munhu anenge ane basa nazvo. After mangoitaura, everyone wants to see kuti chii chirimo. That's how we are wired biologically. Saka ndabvisa zvema odds, you don't have to know it. It's not asked. Okay. What about C? C yati, we want to find the probability that either Tendai or Osame wins. That's C. The probability that either Tendai or Osame wins. apa pakuda kunzwisisa chirungu. Pane ranokwanisa kutsanangura neshona kuti kana tichiti either Tendai or Samuel wins, tiritomborevei? Tikureva kuti vese vanowina here? Tikureva kuti one anowina here? Tikureva kuti vese vanoluza here? What do we mean? Kuti either or, what does it point to? Either A or B. Let us say you are making a choice. So if I choose between either A or B. So you can either pick A, you can pick B, and you are making a choice. Saka kana chinzi probability that either Tendai or Samuel wins. So iri kunzi chance yekuti Tendai anowina kana kuti Samuel anowina ichi. Saka since they are competing between each other, it's obvious that one of them is going to win. Saka this question yanga ichigona kufunzwa ichiti deno wanga chida kuti ive simpler. The probability that at least one of them wins. And the answer is 1. Saka mabvunziro vanoita anoda kuva careful, especially mawedzana either or. Tichazotokuratidzai kuti or kazhinji inoreva addition and inoreva tichazviita, but not today. Saka since one or other of Tendai or Samuel must win, probability of either person to win is equal to 1. Saka zhinji makwestions probability anenge ane ma1 mark haadi kufunga stereki. Zvinongoreva kuti trick iri mumabvunziro avaita, and in most cases the answer is either 0 or 1 or 0.5. Now, if P is the probability of an event happening, then P lies in the range. We've done this between 0 and 1. Saka kana tichida kunyora this range in set notation, saka if P is the probability of an event happening, then that probability P, it lies in the range saka kakuru kuti tanga tida kuirepresent on a number line, it will be something like this: 0, 1. 0 is included as absolutely impossible, 1 is included as absolutely possible, like that. But it's included because it should be solid, like that. The probability of an event not happening is P complement, where P complement is 1 minus P. Let me write it also to move in as my notes. Saka the probability of P not happening is P complement, where P complement is equal to 1 minus P. Anditika? Saka pese pamunonyora the probability of something happening, ndinokukurudzira kuti mubve matonyora paside the probability of not happening. Patanga tichita question yedu apo pataona kuti the probability kuti Tendai awine, taicalculate taona kuti anenge ari 12/15. Ndinokukurudzira kuti mubve matoisa kakoma panapa motonyora the probability of not Tendai win inenge iri 1 minus 12/15, which becomes 15/15 minus 12/15. Saka ndeyani ndi 3/15. This way life will be more easier. The moment yamunonyora a probability, chibva matonyora its complement paside. Chero musina kufunzwa, kutaura kuti kana question ikafunza complement, answer matova nayo. Anditi. Saka an example would be the probability of not winning yatatoita is going to be 1 minus 0.8, which is 0.2. Yamunogona kuwana futi through method yekutanga mambotsvaga kuti how many games did Tendai lose. then the number of games that Tendai lost over the total number of games, then you're still going to get 0.2. Probability can also be described in set language. We wrote this: the probability of R, if R is the event which is happening, would then be the probability of R is equal to, maybe let us write it down as a formula kuitira for your notes. Saka R, this is the event. Saka the probability of R yatinogona kungonyora as small letter p R inenge iri equal to the number of elements in R, kuroti the number of times the event happens, over the number of times of everything. Like this. Example 2. A letter is chosen at random from the alphabet. Saka zvekanzi at random, wedre kuti at random kana mchita probability theory rijairirei. At random, very very important phrasing. At random inoreva kuti there is no bias. For example, class paroda kuendwa kutrip yemahara irongodiwa vanhu 2, the teacher does not want to play favorites. Saka mazita evana anonyorwa oiswa muheti, and maybe teacher obva angodhipa ruoko ononga mapepa 2 overenga mazita aripo ndo vari kuenda. But kana aiswa muheti mukacherechedza muchaona kuti anoshekwa shekwa. Tiri kushekerei? Tiri kuda kubvisa all bias, because kana tikasasheka zvoreva kuti vapedzisira kukanda mazita muheti imomo vane a greater chance yekupikwa. Muri kupaona? Ehe. Saka at random, that is without bias. Saka we try to eliminate all bias. Of course, bias inenge iripo at a very meta level, but we try by all means, all humanly possible means, to eliminate the bias. But if we really look at things mathematically and deep enough, we always find bias. All right. Saka a letter is chosen at random from the alphabet. Find the probability that it is an F. Example 1 yanga iri an example on experimental probability. Tanga tiine past data which we applied kuti tiwane ma future projections kana kuti predictions. But now we are now dealing with theoretical probability where we do not have past data. Saka panapa pari kunzi find the probability that a letter is F. Alphabet ndo sample space yedu, and saka our sample space inenge iri equal to chi. Okay, mondiregerera, this is a mechanical mistake. Inoi statement iri erroneous. Manyora mufunga kuita kuti the universal set is equals to 15, it's incorrect. Mufunga kuti the number of elements of the universal set ndo 15. I always make this mistake. Always. Saka panapa, this is our sample space. Saka sample space yedu ine ma letters of the alphabet. Of course, and amunganyori ese A, B, C, D mchenda. No. Munongo nyora in this way: A, B, C, D, and so forth. Set like this. Saka kana chifunza the probability that a letter is F. Probability of F. Ma F mangana ari mukati me universal set. Ma F mangana i1 chete, and saka tina 1F mukati me sample space yedu over how many letters do we have in the alphabet, English alphabet? 26. Saka tine 26 letters in the English alphabet. Saka 1 over 26. Tiritesera mazangu. Ko tikazenda pa B pari kunzi the probability that it is F or T. Saka indoda kuita nenzira mbiri. Method 1. Saka we already have written down our sample space. Required outcome inenge iri chi f na t, because iko kuti oro zvinorevei takati a or b, murupaona a or b, because you should dwell on this question. It's going to be of vital importance, the difference between oro and and. Oro na and ma keywords in probability. Saka ndichazotsanangura after this kuti kana chiti oro, what do we mean, how do we deal with it, and what do we mean and how do we deal with it. But for now, let us just look at it from first principles. Saka kana zvanzi our required set is going to be containing f na t, because these are the possibilities we require. F or t inoreva kuti we are either picking f kana kuti we are picking t, but hatisi kuziva kuti ndeipi yatichapika. Saka tinoisa zvese, all the possibilities inside our required outcome. Hazvirevi kuti tiri kuda both f na t, but tiri kuda only one between f na t, but hatizivi kuti ndeipi yatichapika. And example ndeyekuti mukutora heti monyora a b to z, moisa tumapepa emomo, mobva mati ndiri kuda kuziva probability yekuti ndichanonga f here kana kuti t. Saka mukanonga f munenge manonga yamuri kuda, mukanonga t munenge manonga yamuri kuda. Saka in this required outcome set munofanirwa kuisa both f and t. Are you following? So zvinoreva manje ndezvekuti probability of f or t inenge ya equal to chi, how many possibilities, e2 over our sample space, the number of elements in our sample space is 26, saka 2 over 26, which is going to be equal to chi 2 into 2 1 into 2 1 into 6 3, saka it's 1 over 13. This is method number 1 of how you do it. Method number 2 inotangira pa premise yekuti oro means addition. Saka kana iri f or t, we are going to add the probabilities. Saka zvamuri kuita apa muri kuti the probability yekuwana f ndeyani, tatoita kudhara ndi 1 over 26. Ko probability yekuwana t ndeyani, ndi 1 over 26. Ko probability yekuwana f or t, zvoreva kuti tichatora probability ya f 1 over 26 plus probability ya t 1 over 26. Since tine the same denominator, we just add my numerators, 1 plus 1 is 2, so it's 2 over 26. Tichawana futi 1 over 3, 1 over 13. Zvafanana guys. Saka mukangoziva kuti oro zvoreva kuti kuedda muchingotsvaga ma probabilities each event mozomaedda. C iri kuti yakaita kakuraba apa, but I think iri kuti one of the letters of the word frequency. Saka tikuda probability, toda calculate probability yekuwana one of the letters of the word frequency. Saka word rati kudila naro ndiani, ndi frequency. But mukatarisa the word frequency rine a trick iripo yokuti kana mukasaichenjerera muno lose ma marks. Muri kuzvionera kuti tine ma e2 handitika pa frequency tine rimwe leta yari kudzokorodza fr qu ncy yatina tine ma e2. Saka mukaita mistake yekuti probability yekuwana any letter in frequency mwenyora yakadai so, moverenga 1 2 3 4 5 6 7 8 9, moti 9 ndo iri kurepresenta our required outcome over 26, munenge maita mistake because you have counted e twice. Saka probability yamenge mchitsvaga imimi, you only take one e. Saka inenge yava fr EQUNCY. Then mukaverenga this 8/26 ndo inenge answer yenyu, which becomes 4 tikatora the half of both 13. Saka this is a trick yavanofarira. Please be aware of it. Because we can see one of the letters of the word table. Saka one of the letters of the word table akwanzi kweseni yati chi not one of the letters of the word table. Saka kana iri not one of the letters of the word table, tikatanga ta calculate the probability of table. And table, remember kuti hatisi kutaura table, tiri kutaura ma letters T, A, B, L, E. Probability yacho inenge iri 5/26. But therefore probability of not table yatinogona kunyora as table complement inenge iri 1 subtracting 5/26 kureve kuti it's 21/26. 21/26, like that. Saka this seals off the examples we wanted to do today. Ndoda kuti zvimbosinga before tatanga mutually exclusive events, which is a different world altogether. Saka kuti at random, it means in a free irregular way without bias. We are trying to control for bias. Then the letter E in part C of example 2 was not counted twice. That's something you should take note of. Then in part D of example 2 is most conveniently solved using the method of subtraction as shown. Kuti totanga tatsvaka the probability of table, tozotsvaka the probability of not table. Saka we are going to use complementary probability. Are there any questions? Saka our next lesson tomorrow tichatarisa anonzi mutually exclusive events. That is what is going to be our lesson tomorrow. So thank you for your attendance and have a nice day.